In this question, you're given a lot of information about what actually happens to the pulleys. And because they're asking about efficiency here, we need to figure out what work in is and what work out is. So we have a mechanic here, and they are using a pulley to pull an engine out of a car. Okay, force out, we know, is 2,800 newtons, and force in is 380 newtons. We know that he pulls the engine out 1 meter, but he is required to pull 8 meters of string. Alright, given that I know these things, I know that the force in is 380 newtons. I know that the displacement in is 8 meters. I know that the force out is 2,800 newtons, and I know that the displacement out is 1 meter. The thing that I'm looking for is efficiency. And efficiency has a formula that of work out divided by work in. That whole quantity times 100. And so I'm going to divide my paper up to figure out what work out is and what work in is. So work equals force times displacement. So in order to get work out, that equals the force out, which is 2,800 newtons, times the displacement, 1. So the work out of the system is 2,800 Newton meters. In order to get work in, I do work equals force times distance. And so in order to figure out work in, I apply 380 newtons, but I do it over 8 meters. So the work in equals 3,040 Newton meters. Now I'm not done yet, I'm really close though. I can figure out efficiency now, because efficiency equals the work out, 2,800 Newton meters, divided by the work in, 3,040 Newton meters. Times 100, and I get 92.10526. If I make that pretty in phase class, it's 92.11%, depending on how you do the rounding rule.